The quadratic function, also known as the parabola equation, looks like this. Y equals ax squared plus bx plus c. The value of the letter a is essential. If a is positive, the parabola opens upward. If a is negative, the parabola opens downward. The larger the absolute value of a, the narrower the curve. If a is smaller, the parabola becomes wider. This isn't just a matter of aesthetics. The direction and shape of the curve can determine whether an object lands safely or misses its target. In engineering, for example, a precise parabola can guide the path of a beam, the reflection of sound, or even how a signal bounces in a satellite dish. That curve is more than math, it's function in motion. But what about b and c? Both also affect the shape of the parabola. The value c tells us the exact point where the parabola crosses the y-axis. The value b affects how the curve tilts, shifting it to the left or right. When you graph a quadratic function, you're not just drawing a line, you're setting up a visual story. The vertex becomes the climax. The axis of symmetry divides the journey in two, and every point along the curve represents a real-world possibility: time, distance, velocity, height. Suddenly, a curve on paper becomes a flight path, a light beam, or the rise and fall of a jump. Let's recap. A decides whether the parabola opens up or down. B affects the tilt and position. C is the point where the curve touches the y-axis. Together, these values define the shape and position of the curve. But the quadratic function is not just theory, it's all around you. Every time you throw a ball into the air, its path follows a parabolic trajectory. You'll also find it in planetary orbits, water fountains, architectural structures, and in technology.